examples we have taken like tossing a coin and rolling the dice. Apart from this probability, we try to understand what are the random variables. Very, very important. Is the screen visible, students?
Yes, sir.
Yes, sir.
Okay,
Yes,
Yes,
sir.
sir.
fine. Yes, very good. So, distribution of random variables. In this lecture, we discuss the different types of random variables and illustrate the properties of typical probability distribution for this random variables. So here, students, we are going to study what are random variables, where we come across discrete random variable, continuous random variable, and then we also come across binomial distribution, Poisson's distribution, normal distribution, and exponential distribution. So before this, we'll just ask very simple question: what is random variable? So random variables is nothing but data. Okay. A variable is any characteristic, observation, or measured, or the value changes. We say such terms as variable. Suppose if I take A, it is an alphabet and it is variable. The value is not fixed. If I take X, if I take Y, if I take Z, these are the variables and they are the alphabets. The values are not fixed. So a variable can be either random or constant in the definition of interest. Note this differs from common English usage where the word variable implies something that varies from individual to individual. For a defined population, suppose if a defined population, every random variable has an associated distribution that defines the probability of occurrence of each possible values of that variable. So means for every possibilities outcomes, random variables will be different, and for every random variable there will be associated distribution which will be going to define its probability. So if there are finitely countable number of unique values, this is one of the possible variable, or all the possible sets of possible values. Suppose the variable is defined on a real line, then we get sets of possible values. Means what is actually a random variable? In most statistical problems, we are concerned with one number. Yes, definitely we come across one number. But this if this number few numbers that are associated with the outcome of the experiments, then we get different values. So we say they are the random variables. Suppose if it, I think your labs are going on, you are conducting the experiments, yes, but everyone will get different values. So what are the outcomes? They are random. They are values which are varying from individuals. Therefore, these experiments, we say, from these experiments, whatever outcomes we are getting, we call it as a random variable. In the inspection, we'll take one another example, that is manufactured products. We are interested in defectives, suppose. So how you are going to test this? Are you going to open all the manufacturing products? No, it is not possible. So we just test these products by their average speed. We are interested only in average speed and the average fuel consumption. Definitely. Suppose if we have a vehicle, we try to see its fuel consumption. If it is less, we say it is good and manufactured product is there is no defect. Suppose its speed is getting less, yes, then we say there is some defective in the manufacture. So like this, we only specify very little. Suppose if at home one bulb is there and it is consuming more current, then we say the bulb has some defective. So we just are interested in defective term. Suppose if your mobile is there, If you are charging in 1 hour, if it take time to charge 1 hour full battery, then within half an hour if the charging get, yes, it discharge within half an hour, then we say this is defective. Not defective, but only by looking at its battery consumption, we say it is defective product. So like this, manufacturing products are there. So all these numbers, we collect the numbers which are associated with situations involving an element of change. So already I told you, random variables are what? The elements of chance. How this chance is there, it differs from individual to individual. In other words, they are value random variable. So we study random. We are usually interested in their probability distribution, namely in the probabilities with which they take on the various values in their range. So we say that is the range. We'll just go with one example: tossing a coin. So what are the outcomes? Head and tail. Already we have discussed. Tossing a dice. Outcomes are integers, that is 1, 2, 3, 4, 5, 6. So these are the integers. So every example has different outcomes. However, we frequently wish to assign a specific number now to each outcomes. Suppose I will conduct an experiment tossing a coin. I will assign 1 to head, assign 0 to tail. So remember, I will ask one, okay, after later class, that if I assign one, what is the one assigned? To which outcome? It is head. And I have assigned 0 to the outcome tail. So this is how assignment of numerical values. Assignment of numerical values is called random variable. So very important, student. Random variable numerical variables. So more generally, we have the following definition. So for our study, a random variable x is a rule that assigns a numerical value to each outcome in a sample space yes. Is it clear? So what to say? Random variable are assigned to a number for each outcome in a sample space. In other words, if f is a function from S into the set R of all real numbers, then we take x. I already told you capital X is called random variable on S. For this experiment, the sample space is S is equal to H comma T. Suppose if I take the sample space H comma T, then how we can take this as variables? Yes, we can take the variables 0 and 1. Already I have told you that S of S tending to R by f of s is equal to 1. So remember this, very important. This one, f of s is equal to 1 if s is equal to h. Already told you, when I take head, will assign 1. Random variable will assign the value 1. If I take s is equal to t, will assign the random variable 0. Suppose if I take two random variables, and if I take a and b are two real numbers, so what will be the random variables? So you can see ax plus by is also random variable, x into y is also random variable, 1 divided by x is also random variable. So these are the some properties if we take two random variable x and y. Okay, students. So we'll go with the another very important definition. The event consisting of all outcomes for which x is equal to x is denoted as x is equal to x, and the probability of this event is denoted as p of x is equal to xi. So I will just explain you once again. An event we are going to conduct which consists of all outcomes. Fine. So here, how we are going to take the probability of events? So P is nothing but probability, X is nothing but our outcomes, that is the random variable, yes, and Xi are the different outcomes. That is, if you take a coin, there will be 0 and 1, 1 and 0. If you take a dash, so there will be outcomes 1, 2, 3, 4, 5, and 6 outcomes are going to be. So like this we denote. So random variables are classified, very important. I will ask you in between anybody, how many classifications are done in random variable? There are two classifications. One is discrete random variable and another one is continuous random variable. So we just see what is discrete random variable, students. They are nothing but it is the assumed value in steps. Remember this. What is discrete random variable? They are the variables which we count numbers, most countable numbers of values. We say discrete random variables. Remember this. Now we come across continuous random variable. What is continuous random variable? This assumes all the values between 0 and 1. If I draw a line and I tell this is 1, so if you divide this 0 and 1, it is continuous. There is no stop in between. It starts with 0, it will end with 1. Like if you go to integration, upper limit and lower limit is there. So it is continuous. Integration is continuous. Therefore, we take this variable, random variable as continuous random variable. For example, we go with one example. Defective items in the manufacturing, if you see defective items in a lot, it is discrete, means it is fixed. It is discrete random variable we get. Suppose if I give another example, that is length of life of electric bulb. Can you tell me electric bulb will be there, will be working for 1 year, 2 year? It is not. We cannot count the years. The life of the electric bulb is not fixed. So it is, we say this example is for continuous random variable. Suppose immediately we'll go with one example. In the experiment of tossing two coins, suppose if you take two coins, we assign uniform probability to each element of yes. So here in this, I will consider random variable x which assigns to each element of yes. I will take this random variable, I will fix, which is your number of heads in that element. So number of heads, can you tell me how many number of heads are there here? 2. Here 1. And here in this we have 1 head. And here it is 0. Means what is the random variable? Here 2 variables. So I will take x is equal to 2. Here 1, x is equal to 1. Here in this outcome we have 1. And here it is 0. 0 heads are there, therefore I assign this as 0. So means thus, I will write like this now. X S tending to R is given by X, that is a random variable, HH, 2 variables, 2 heads, 2 variables, and X, that is a random variable, HT is equal to X and random variable 0, because no 0 variable have assigned it as 0. So number of heads now. In the first outcome, there are 2 heads. In the second, there is only 1 head. In the third, it is 0. So I have taken this as 2, 1, 0. Means the range is now. Just remember this range. I am going to use this range for the next example also. So range x is equal to 0, 1, 2. Therefore, the probabilities of the events are. So we'll find. Already I have told you we are interested in probability of random variables. So remember how to identify. P is nothing but probability. I will take here 0. This 0 I will take. Why I have taken this 0? Because variable is 0. That is in TT outcome. TT outcome variable head is 0. There is no variable. So there is no variable variable, so I have taken random 0. So therefore I have taken now directly x is equal to 0. So probability of this, how you find probability of this, students? Because here only one outcome, see tt is only one outcome, but variable is 0. So means, therefore this is 1 divided by 4. Please remember this. I'll go for second case now. P of x is equal to 1, which is equal to 1 upon x is equal to 1. When I take x is equal to 1, you can see here there are two outcomes. When I take x is equal to 1, there are two outcomes, that is ht, th. Means, what is the probability? Yes, it is two outcomes divided by total number of outcomes. Therefore, it is 1 divided by 2. Similarly, I will go for probability of x is equal to 2. 2 means two heads, two variables. Means their outcomes are only 4. Outcome is 1. So what is the probability? 1 divided by 4. Okay, I'll repeat this once again, student. Please remember, x is equal to 2 because two variable h is variable. So x is equal to 2. The random variable is 2 h. But outcome is 1 h. Therefore, probability of this x is equal to 2 is 1 divided by 4. 4 because 4 outcomes h, th, ht and tt. These are the 4 outcomes. Therefore, probability will become 1 divided by 4. So immediately we go with the definition. Next definition, what is probability distribution? Distribution f of x of random variable x is a description of the set of possible values of x. So that is the possible values of x are what? Range of x. So in the last example, you have seen the range 0 with each of the possible values of x. So you have seen what are the possible values of x. So this is our probability. Yes. Similarly, we have this is our probability. So we have what we have done. We have done probability distribution. So you can say this x is equal to x. This small x is nothing but 0, 1, 2. With their probability, we get the distribution as when it is 0, we get 1 upon 4 because only one outcome, that is t. When I take x is equal to 1, that is ht or th. So there, that is the h. So 2 divided by 4. So if we cancel, we are going to get 1 divided by 2. Similarly, if you go for the second one, two variables. In these two variables, only we have h. Probability will become 1 divided by 4, students. Okay, this is clear now. Probability is clear. Probability distribution is clear. Okay, I will repeat once again. An x 0 variable, outcome is tt, only one is there. So probability will become 1 divided by 4. I will go with next one. X is equal to 1. One variable, random variable. Sorry. So two outcomes. Probability will become 2 divided by 4. If you simplify, it is going to become 1 upon 2. Next step is equal to 2. Two variable h, but one outcome, that is 1 divided by 4 is the probability. So immediately we'll go with the definition of next definition, that is cumulative definition. So what it says, the cumulative distribution function for random variable x is defined by f of x. So f of x is nothing but cumulative distribution function for random variable x. And what is this equal to? Probability x is less than equal to x. Here we have seen x is equal to x, but here in community distribution, we take x is less than or equal to x. So x may be any real number, student. This is very, very important. In the examples, we come across this. So x is nothing but from minus infinity to plus infinity. So immediately we'll go with some important properties of cumulative distribution. Two important properties of f of x are given by. So one is if a is less than b, then p of a is less than x is less than equal to b, which is equal to f of b minus f of a. So this is one of the important property. Next property what we have, p of a is less than equal to x is less than equal to b is equal to p of x is equal to a plus f of b minus f of a. These are the just properties of cumulative distribution. The next definition, well, very, very important, that is the discrete probability distribution. So already I have told you, this is very, very important, students. Discrete probability distribution. So what it defines? Yes, it defines like this, students. Let x be a discrete random variable. The discrete probability function f of x for x is given by, so like this it is given, f of x is equal to p, x is equal to x for a real x. So this is how the discrete probability distribution, already we have come across the definition. Immediately we'll go with one example. We have already done this example. Little change I have made. Here I am going to take 3 coins, students. So can anybody tell me that if I take 3 coins, right? Can Raj tell me, if I take 3 coins, what are the sample space or what are the outcomes we are going to get?
Sir, 8 outcomes.
Yes, very good, excellent, done, finish. So remember this. So there are 8 outcomes when we take 3 coins. If I toss 3 coins, I'm going to get 8 outcomes. So I will name like this. First I will take 0, 0. When I take random variable and as usual heads, number of heads, I'm going to take x is nothing but number of heads. 0 means what is the outcome? Yes, can Uma tell me what is the outcome?
Sorry, sir?
Yes, if I take number of heads and number of heads are 0, so which is the outcome?
0.
I I am giving assigning the value as 0. Number of heads are 0. But what is the outcome is known as? It is tail, tail, tail. Outcome is tail, tail, tail. Only one outcome. So remember, what is the outcome? One outcome.
Okay.
Understanding? How many heads are there? 0 heads are there. What is the outcome? 1 is the outcome. That is T, T, T. So therefore, what is the probability we get? 1 divided by 8. Okay. Similarly, we'll go with only one variable. Yes. Can Saurav tell me, if I take as one variable, how many outcomes you are going to get? Saurav, are you there? Yes, Saurav. Okay. Sachin. Yes. Okay, fine. I will tell you. If there are 3 outcomes, how 3 outcomes? It is STT. Fine. THT and TTH. 3 outcomes are there. Therefore, what is the probability? 3 divided by 8. Similarly, we'll go with the second one. 2 variables. 2 variables means heads must be 2. How? HHT. HT. Okay. THH. So again, how many outcomes? 3 outcomes. Probability 3 divided by. Yes.
So for
Yes.
the x equal
Tell
to
me.
0, how probability is 3 by 8?
Hey, x. When it is x, remember probability is 1 upon 8. Okay.
Sir,
Why
printing
it is
mistake.
zero? Because 1 upon it. It is little bit front, I think, right? When it is zero, probability is 1 upon 8. When it
Okay,
is
okay, okay,
1,
okay. Printing mistake, sir. Okay.
3 upon 8. When it is 2, it is 3 upon 8. When it is 3, it is 1 upon 8. Means how? 3, what is the 3 probab 3? If I take x is equal to 3, what are the outcomes? Can anybody tell me? Yes, Saurav, can you tell me?
1 by
If I
8,
take
H,
x is
H,
equal to
H.
3.
1 by 8.
Excellent. This is simple. It is 1 upon 8. Very good. So if I take x is equal to 3 means 3 variables. What are the 3 variables? H, H, H. And outcome is 1. Only 1 we are going to get the outcome. So it is going to become 1 divided by 8. Okay, so this is very clear now. Understood? Okay. So we'll go with immediately the properties. So some properties will come across in the discrete random variable. You can see just properties that identify a probability function or a discrete random variable. That is, first one will go take f of x is greater than or equal to 0 for each real number x. Second one will go with summation. Sum of all these functions will be always equal to 1. I think in the last class I already told you that whenever you collect all the outcomes, suppose this is 1. In the previous example, you can see 1 plus 3 plus 3 plus 1. So how much it will be? 4, and this is 4. 4 plus 4, 8. 8 divided by 8, it is always 1. So sum of all these probabilities, all these functions of discrete random variable is 1. So this is 1 plus 3 plus 3 plus 3. So all together, you're going to get the function will become 1. Remember this, student. So in this, if you just take any in between value, if you take, it is always less than or equal to 0. We are going to take these values. Immediately we'll go with the next one. Note that the discrete random function f of x can also be called as probability mass function. Very, very important, students. What we take, note that the discrete probability function f of x can also be called as probability mass function. So if I ask anybody, yes, Saurav and Raj, if I ask what is probability mass function, you have to say it is nothing but discrete probability. Now I will ask everyone, check whether the following can serve a probability function. Yes, is it discrete probability function, students? Can anybody tell me, is it discrete probability function? Yes, Uma, can you tell me it is discrete probability function? 1 and 2, I have given A and B. Which function is discrete probability function? I will tell you once again. I will go back to the last slide. It is not going same. For discrete probability function, what I told you, f of x must be greater than equal to 0. This is the condition, remember. And sum of all the functions must be equal to 1. So I will tell you, see, substitute x is equal to 1. 1 minus 2 is minus 1. Minus 1 divided by 2. It fails. Why it fails, student? Because it is negative. We cannot take the function negative. It must be equal to 0 or less than 0. Therefore, not discrete probability function because it is negative function. Similarly, if you go for the B1, can anybody tell me B is discrete probability function or not? If you substitute the values, yes, Saurabh, B is discrete probability function. Yes, yes, it is discrete probability function because 0 divided by 25. We get How much?
0.
0.
Yes, 0. So it is h of x is equal to 0. Then if I substitute 1, definitely it will be
Less than 1.
greater than equal to 0. Yes, less than greater than 0. Sorry. See, means it is this function satisfies. Therefore, it is clear that B is a discrete probability function. Yes, am I clear? Okay, for the given values. So immediately we'll go with the sum of the axioms. So axiom 1, 0 is less than equal to P of A, that is probability of event A is less than equal to 1 for each event A in yes. Remember this axiom student, very very important. This will tell you where the probability lies. It is from 0 to 1. And don't tell me that, sir, I got probability 1 point plus how the, you have to understand the in the exam probability or 1. Don't tell 3. 3 we that is not at all probability, means you are not understood the probability. This is how we have the axiom. Next, always probability of sample space will be equal to 1. Remember, I already counted here, right? What is that? 1 upon 8 plus 3 upon 8 plus 3 upon 8 plus 1 upon 8. All together will become 8 upon 8, which is 1. So this is our condition that axiom P of S is equal to 1. The probability of some events occurring from S is always unity. Remember. So if you take, if our third exams will go, A and B are mutually exclusive events in S. So already in the previous class I have already given the definition of mutually exclusive event. Means what? Two events happening at a time, that is P of A union B. If you go to Venn diagram, P of A union B is equal to P of A plus P of B. Obviously, if we have two events and two probabilities, if we get, we can add them directly. So that is what we say. Probability function is an additive set function. Means we can add the probabilities. That's it. So these axioms do not tell us what the set function P of A is. Only what probability it must satisfy. Means these three conditions must satisfy the probability. Then we take the probability functions. Is it clear, student? So next definition expectation will take in the next class. I think it is clear now. Yes. So this is what I wanted to convey you, that probability function is easy. Yes. Can Raj tell me, is it easy? Probability, have you understood?
Yes, sir.
Yes, just simple formulas they have given, simple definitions they have given, and they have told you to simplify this.